Bismillahirrahmanirrahim. In this video, we'll learn about Thevenin's theorem with dependent source. Now, there are two cases that we'll discuss. In the first case, we'll have circuit with only dependent source and no independent source. In the second case, we'll have circuit with both independent source and dependent source. In the first case, where we have only dependent source, the output voltage VAB or VThevenin will be 0 because there is no independent source in the circuit. In the second case, we can find the V output or VAB or VThevenin by the normal methods that we have learned, that is either by mesh analysis or nodal analysis or any other techniques that we have learned. To find RThevenin, we'll proceed as follows. For the first case with dependent source, there are two methods of finding RThevenin, and for case 2, we'll have three methods of finding RThevenin. So the first is that we can connect a 1 voltage source as a test source. So like we have connected here, so test source is connected, and then we try to find the current I naught, and RThevenin is found by the test voltage divided by the current I naught, so 1 volt divided by current I naught. There is another way that we can connect a current source of 1 ampere, test source of 1 ampere, and then we try to find the voltage V naught. So if we can find V naught, we already have current 1 ampere. So RThevenin is V over I. So V naught over 1 ampere will give RThevenin. In case 2, there is another option or there is another way, that is we short circuit the terminal. So by short circuiting the terminal, we can also find RThevenin by this formula. So RThevenin in this case is VThevenin over I short circuit. So let's start with an example. This is with only dependent source, and we have to find the Thevenin equivalent. So as we have learned, since there is no independent source, therefore the output voltage VAB or VThevenin will be 0. So straight away we will write that VThevenin is 0. Now to find RThevenin, in this case I am applying a 1 volt test source. So we connect at this point a 1 volt test source, and then our aim is to find I naught. So the best way is to solve by nodal analysis. Now since this voltage V naught here, V naught, so V naught is across this, V naught is across this, and V naught is across this. So the nodal voltage we'll name is as V naught. Now by KCL, we can write the current entering I naught and Ix, and current leaving I1 and I2. So I1 plus Ix is equal to I1 plus I2, and then from here we can see that I1 is actually, there is a current source which is 2Ix. So for I1 we write 2Ix, and I2 is in terms of voltage V naught divided by 4. So V naught divided by 4, and from here we can find I naught to be equal to Ix plus V over 4. Now what is Ix? If you look at the circuit, Ix is V naught over 2. So we'll replace that. So for Ix we'll write V naught over 2, but in the negative direction, because V naught over 2 will be current going the other way. So we can also write it negative V dot over 2, then V dot over 4 here, and from here by solving we find I dot to be 0.25. Remember that this V dot is same as the test voltage that we have taken, so for V dot we put 1 volt divided by 4, so I dot is 0.25 ampere minus. And now we have learned the formula for R Thevenin to be V dot over I dot. So V dot is 1 volt, our test voltage, and I naught we found to be 0.25. So our answer is negative 4 ohms. Now what is the significance of negative 4? That we will learn at a later stage. Another example of the dependent source only. Again, as we have learned that for the dependent source only, V Thevenin is equal to 0. So V Thevenin is 0. And to find R Thevenin, as we discussed earlier, that we could either connect a voltage source of 1 volt or you could connect a current source of 1 ampere. So in this case, just to give you an idea, I am connecting a 1 ampere current source. And the aim now is to find V dot voltage. So since V dot is across this, that was V dot is the node voltage, and by either nodal method or any other method we can find the voltage V dot. Nodal I prefer, so we'll go by nodal method. So we take the two currents I1, I2 and I0 entering by nodal analysis. Entering current 1 ampere and leaving current I1 and I2, and the techniques that we have learned, by that you can now write I1 is going from V naught to ground, so V naught, and this current is also in the same direction, so we'll add V naught plus 4Vx, this voltage, so V naught plus 4Vx divided by the total resistance. Similarly, I2 is V naught over 15 and equal to 1 ampere, and from here we simplify. So we have now 4Vx plus 2V naught plus 15. We have to get rid of one of it. So what is Vx? If you look at the circuit, this current I1 multiplied by 5 is Vx, and the current I1 is this one, so we'll multiply this by 5 to get Vx. So look here, Vx is I1 into 5 and I1 is V naught plus 4Vx over 15, same here. So we write that, and by simplifying, now we get Vx is equal to minus V naught, so we put that here, and from here we find V naught to be minus 7.5 volt. So we have found V naught, we know the current, so we can find R Thevenin, V naught over I naught, so minus 7.5 over I, and that is negative 7.5 ohm. So these two examples we did for dependent source. Let's do some examples of circuits with independent and dependent sources. So here's an example. Now in this we have dependent source and independent source. We need to find VAB or V Thevenin first. V Thevenin. Now since there is no current flowing through the 10 ohm resistance, therefore the voltage here and voltage at this point the same. and we can find a VThevenin by KVL method. So we just follow in this loop, minus 20, 6i minus 2i and 6i equals 0. From here we find I to be 2 ampere. Now VThevenin will be 6 times I. So VThevenin is 6 times I is 12 volt. So we found VThevenin. Now we need to find RThevenin. Now for RThevenin, remember that if we have an independent source, we have to make that source 0. So there was a voltage source here. We are now making that source as 0 and connecting either a voltage source of 1 volt or a current source of 1 volt, or we can also do it by short circuit, but in that case then we have to keep the source there. So let's do this example by connecting a 1 volt test source. The aim again is to find the current I naught. Okay, so by KCL we have taken 3 currents, so I1 and I naught entering and I leaving, and now in terms of voltage, 0 minus V1 plus 2I, and the other one is 0 minus V1 for I, 0 minus V1 plus 1 volt divided by 10, and I is V1 over 6. And by solving this, we get a simplified equation, and putting the value of I in this case. So what is I? I is V1 over 6, and simplifying we get V1 to be 0.264 volt. Now if you want, you should pause this video and go into details of working as to how I got this equation. And now we are interested to find I naught. So we have seen from here, this is the equation for I naught. So I naught is this. We found out V1 from here. So put the value of V1, and now we find I naught to be 0.763 ampere. So we have V and we have I naught. So we now find RThevenin is 1 volt divided by I naught, 1 over this. So it is 13.58 ohm. Now the same problem we can also do by taking a current source. And this is just to give you an idea that we can solve the same circuit by more than one method. So if we take a current source, in this case now we want to find the voltage V naught. Now remember, since the circuit is now complete, so V naught is not V1, it's different, so we have to find V naught. So first find a V1 and then we'll find V naught. Again, by the nodal analysis, current entering and current leaving, writing the equations, we find this equation, which is V1 and I. So we need to replace I from here as we did earlier also. So I is V1 over 6. So we put V1 over 6 and then we find V1. Now, as I mentioned earlier, that V1 is different from V naught, so we need to find V naught. And if you look at the circuit, you can easily find V naught from the current direction here. So you can see that I naught is V naught minus V1 divided by this resistance. So if you take this terminal, so I naught can be written as V naught minus V1 is going from here divided by the resistance 10 ohm. So from here you can find V naught to be 13.6 volt. Now if you have found V naught and you know already I, so R Thevenin is found by V naught over I naught to be 13.6 ohm. We'll also use the third technique, that is by short circuiting. The same problem, but remember that when we short circuit, we do not eliminate the independent source. What we have done here, we have shorted the output and we have not eliminated the independent source. Our aim is to find the short circuit current, ISH. Again, we'll take the nodal analysis, or we can also solve by the mesh analysis technique. So here we are doing my mesh analysis technique. Loop 1 minus 20, 6i minus 2i and plus 6i1 minus i2. This is our first equation. In the loop 2 we have equation 6i2 minus i1 plus 10i2, and we can also have another equation of current I, which is i1 minus i2. So by solving these three equations, we can find the I2, which is actually I short circuit, to be 120 over 136. Now once we have found I short circuit, the R Thevenin is V Thevenin over I short circuit. So V Thevenin we calculated to be 12 volt divided by I short circuit is again 13.6 ohm. So we did the same problem by three different techniques, just to give an idea. You can just follow any one technique, whichever you feel more comfortable, to find R Thevenin. Here's another example, similar type. We have to find the Thevenin equivalent. So first of all, we need to find VAB. By nodal analysis, we have taken the KCL equation here, and by solving details, you can find the V Thevenin to be 5.33 volt. So I'll not explain this in details, but you can pause the video and go line by line. I'm sure you'll be able to follow this. We could also have done this by mesh analysis. So you can see that between two mesh we have a current source, so this becomes the super mesh. So by writing two equations, you can find V Thevenin, which is the voltage across 4 ohm resistor. So again you find V Thevenin to be 5.33 volts. So these two techniques, you can follow any one to find V Thevenin. Now we need to find R Thevenin. Again we have three choices: by connecting 1 volt test source, or by connecting 1 ampere test source, or by short circuiting. So we are using 1 ampere current source, and we have eliminated the independent voltage source by short circuiting. So this circuit is same. Now we are using source transformation technique. So transform this part into a voltage source along with the resistance in series, and then you write the two loop equations, loop 1 and loop 2. Remember, we need to find I naught, that is I2. So solving these two equations, we find I naught to be 2.25 amperes and R Thevenin is now voltage 1 volt divided by the current is 0.44 ohms.